Example 1. The increase in the Consumer Price Index, or CPI, for the year 2000 was 3.2%. This means that prices increased an average of 3.2% from the previous year. A pair of designer jeans cost $89.99 in the year 2000. If the cost of jeans increases at the same rate as the CPI, determine the cost of these jeans in 2003. Assume a constant CPI increase. So let's define our variables. Okay, it says determine the cost of the jeans. So that means Y is going to represent the cost of the jeans. And we're trying to find the cost in 2003. Okay, so the cost will depend on how many years have passed since the price has been decreasing. So X is going to represent the number of years since 2000. This is important, okay, because the price is not going to increase 2003 times. It's only going to increase for 3 years, since there's 3 years between the time it started increasing and 2003. Okay, we're going to model this with an equation of the form y equals k a to the exponent x. K represents the original price of the jeans, which is from the question here, it's $89.99. And a represents the number that we're multiplying by. So in order to determine that number, let's think about how much you would pay at the cash register when you're buying an item, and tax is added on. Okay? Tax is 13%, so you're paying 100% of the price plus an additional 13% of the price. So you're actually paying 113% of the price. To find 113% of some number, you would convert 113% to a decimal, because percent means out of 100. So if we take 113 divided by 100, we get 1.3. The word of in math means you're multiplying. So to find out how much you're paying at the cash register when you're buying an item, you would multiply the ticket price of that item by 1.13. The same scenario applies here. Here we have an increase of 3.2%, not 13%. So that means we take 100% and we're going to add 3.2% to that amount to give us 103.2%. If we're trying to find out what 103.2% of a number is, we would divide 103.2 by 100 to give us 1.032 and multiply by the number. So what are we multiplying by? We're multiplying by 1.032. Okay? This is the equation that models this scenario. So now let's find out the price of the jeans in the year 2003. So if we're looking for the price of the jeans Y in the year 2003, we would sub in 3 for X, since X represents the number of years since 2000. And then we would enter this into our calculator to give us an answer of $98.91. Therefore, in 2003, the jeans cost $98.91. Okay? Let's look at example 2. In example 2, it says a new car costs $24,000. It loses 18% of its value each year after it is purchased. This is called depreciation. So we have a percent decrease instead of a percent increase, as in the last example. It says determine the value of the car after 4 years. So what are we asked to find? We're asked to find the value of the car. This is what Y will represent. The value of the car depends on the number of years that go by, since the value depreciates or loses its value every year. So X is going to represent the number of years. We're going to model this with an exponential equation of the form y equals k a to the exponent x. K is the initial price of the car. So the initial price of the car is $24,000. Now we have to figure out what we're multiplying the price of the car by each year if it's losing 18%. So similarly to what we did a percent increase, we're going to start with 100%, but this time we're losing 18%. So we have to subtract 18% from 100%, and that's 82%. So we're only going to be determining what 82% of the car's price is from year to year. So if we're looking for 82% of some number, we would have to divide 82 by 100, since percent means out of 100, and multiply by that number, since of means multiply. So the number that we put inside the brackets here is 0.82. Okay, this is a decay factor since the value is between 0 and 1. To find out the price of the car after 4 years, we would sub in 4 for X and evaluate using your calculators. So when we do that, we would get an answer of $10,850.92. So therefore, after 4 years, the value of the car would be $10,850.92.